Hi, this is Janos, it's Revert Audio, and we will be talking about single drivers again and a little bit about what can you do when you don't like the Wizzer Cones. And I'm coming back to the Fostex 208 Sigma, and I'm showing this because I have designed void pipes for my friend, and he used these drivers with them, and he built them from spruce. Yes, spruce void pipe. And all I can say about them is that these were one of the finest speakers I ever heard in my life. He used them with 300B amplifiers made by the Hungarian master transformer winder and tube amp designer and maker Danish Peter. His company is called DPA. I don't know if he still makes audio equipment. He's probably retired by now. And but he is quite a legend. And if you see any DPA stuff coming your way, or you find something coming up for sale somewhere, grab it, because you will be in for an amazing treat. His output transformers are of insanely crazy high quality. And anyway, so going back here, why I want to show it is because this is like a perfect example to show what a Wizzer Cone does to the sound and how does it change the colorations. So before I really talked about what an unbalanced Wizzer Cone can do to the sound in the high frequency region. And one of the issues can be like above the 10 kilohertz region. So it was just way high up in certain drivers, and also in other implementations it can be just way down. So that's one aspect of the Wizzer Cone, because the Wizzer Cone does two things. It affects the mid-range, the upper mid-range, and it also affects the high frequencies. So those things, and that's why it's so darn hard to design a proper Wizzer Cone, because you want this high frequency extension that we see here, but you don't want added mid-range, added upper mid-range, that 2 to 5 kilohertz range that can have problem with Wizzer Cones. So here you see those two humps. One of the humps is around like between like 2700 hertz and to 3.1K, and the second one is centered around 4 kilohertz. So there's these two humps there, and these would be of the most interest to us because the human hearing is the most sensitive between 2 kilohertz and 3 kilohertz, so this region. So what we have here is that up to, let's say, about 2500 kilohertz, there's no noticeable Wizzer Cone artifacts. These kind of things, that's normal for any loudspeaker. Even if you have just a dedicated mid-range driver, you're going to have this sort of variations. And here we have like maybe like a dB or two bigger variation than with a dedicated mid-range driver, but it's not prominent, and the energy is not kept through the entire range. So basically we have a little peak, comes down, and another peak, and then for the 5K plus it doesn't go higher again. So basically this driver, this Wizzer Cone, does not add a very hard stamp on the sound. It adds a little bit, it's a very light thing. And I can tell you guys that in real life, this driver in my void pipe, it doesn't have any mid-range forwardness to it. It sounds like a very balanced loudspeaker. And when you look at the FE204, that's my driver, and actually I designed Akoshi's speaker with this because they stopped making the FE204 shortly after I got it, and then this was the closest to it that I could use as a replacement. And when you look at the FE204, it has an even better frequency response curve, because that 2 kilohertz through basically 2 to 5 kilohertz, we just have very, very little valleys and dips, just like plus minus 2 dB from its center line. And at the upper mid-range, it's not adding any significant extras. And as you see, it's rising a little bit, but when that's on axis response, but as we go off axis, then this whole thing starts tilting lower, and basically by tilting the speakers, you really get a flat response curves, and the driver, I mean the Wizzer Cone, is extremely well integrated with the driver. And as I said in my previous video, I could only hear its contribution when I had issues with the room. And okay, what else? What else I wanted to say? So now what I really wanted to say is that, of course, if you don't have any issues with your system and with your room, then you won't have issues with the proper Wizzer Cone. And you can say that by looking at the frequency response curve, and just look from this plateau bit to the part where it starts to roll off, put your pencil there, and if it's a flat line, then that's what's going to tell you. Or like here, another example, still flat line, then you won't have Wizzer Cone artifacts in a really good room, in a really good system. Now, what about if you have a bad sounding room, which might not be bad sounding at all, but it's acoustically imbalanced? Or you have problem with your audio gear that has, let's say, like metallic sound or high frequency instability, which will be greatly magnified by a single driver speaker, and due to and not because it's incapable of reproducing anything, but because there is no crossover between the driver and the amplifier. So when you have a multi-driver speaker, the crossover negotiates the energy between driver and amplifier and does a lot of smearing. And that smearing, it smears a lot of errors that your amplifier does, that your amplifier has. And it also smears a lot of the acoustic feedback energy that comes from your loudspeakers and fed back as a back pressure to the amplifier. You know that when you have a cone, let's say this is our loudspeaker cone here, and it's creating sound waves. The amplifier is not just creating those sound waves, but there will be reflections coming back from the room, bouncing back and pushing on the cone. And that's acoustic feedback that goes back to the amplifier. Now, if there are problems with these reflections, you have resonant peaks at certain energies, then that's going to go back to your amp and create a havoc if you have a single driver. Now, if you have a crossover here, so you have inductors, you have capacitors, you have resistors, and it's a vastly complex network of them, then whatever energy is coming back, it's going to get stored in the capacitor and redistributed to additional energies. Same thing with the inductor. It's going to smear the voltage, the input voltage that was fed into an inductor. That's what the inductors do. They smear energy. Resistor, it's going to change the value of it. So the work of these three different guys in a crossover, and you look at many loudspeakers, especially modern ones, they're proud to have supremely complex crossovers. And means that they do a shitload of smearing. So the energy that's coming from your speaker going back to your amplifier will be vastly modified. And there's a lot of, so basically smeared. That's the best way of putting that. It's going to smear the out of it. And that's why it will sound smoother. So when we cut out the crossover, because with single driver speakers, there is no crossover. So this means that whatever is coming from your room is directly going back to the amplifier. It acts as a microphone. So basically it picks up everything and feeds it back directly. And the same thing, whatever comes from the amp, there's no filter, there's no smoothing, there is no smoothing of like extra high or ultra high frequency energy that the loudspeaker is reproducing, which is not part of measurements. When they measure amplifier, that traditionally don't publish very high frequency range, what's going on there. So maybe you get a perfect solid state amplifier with a perfect 1 hertz through 40 kilohertz response, but what's happening at 200 kilohertz? Maybe it's a nightmare on the Amp Street squared, and you don't know about it because it's not published. And all the manufacturers are smart not to publish compromising data. So going back to here, because you have that sort of thing, that's why in some rooms you will have problems and with systems, and people tend to attribute it to the Wizzer Cone, and because it's all going to happen, or the most of it is going to happen where the driver has the most energy, the most output. So in this case, as you see, it has here, which is 2 kilohertz and 5 kilohertz. So basically that's the energy where the the Wizzer Cone starts to pick up. And that's why we call it attributed to Wizzer Cone distortion. Now, what if that, for example, you can't change your room, you don't want to change your amplifier, so your choice is to change your speakers. So then, if you want to experiment with single drivers, it doesn't mean that now because of the Wizzer Cone, the single driver is off your menu. There are single driver speakers such as the Daton 610, which are single driver but do not have a Wizzer Cone. And let's look at the frequency response. Sorry, the driver is in the box, so it's a little bit heavy. And as you see, look at that. This is the flattest frequency response I've seen from any driver, period. Is just freaking astonishing, and it's not smoothed out. So you can see, if you look closer, that there's like tiny squiggles all over. So this is like a really fine resolution that they made it with, and it's not smooth because it's been smoothed out. But this is the real deal. And here there's no Wizzer Cone. As you see, here's 2 kilohertz, here's 5 kilohertz, that region, and there's absolutely zero additional energy at that range. And when you go to the high frequencies, zero additional energy. So this is one choice that you can do if you don't like Wizzer Cones. And even though there's a chance that with the appropriate gear and appropriate room, you would find them acceptable, but in your specific case, with your room and system, they are not acceptable yet. Those full range drivers, which don't have Wizzer Cone, they will not have those faults that we could attribute to a Wizzer Cone. And what I just showed, the Daton driver, is one such driver. And I can tell you guys, because Klaus made that comment that he tried single drivers and he absolutely didn't like them, is that because of the Wizzer Cone, then I would really recommend that, and I would actually predict that he would really like these Datons, because I heard them A/B tested against the Voice of the Theater A5, and it sounded just like the 8.5 in a smaller cabinet. So it was so mind-blowing, because those of you who know, the A5s are just gigantic, enormous speakers, and we had the baby diatoms next to them. They were like 20 times smaller cabinets, just like a joke. But if you would to listen to them side by side, blind tested, I mean just blind listening, then you would have thought that the diatoms are sitting in a 100 to 200 liter cabinet, and they were just a 30-liter cabinet. So single drivers can sound really, really different from one the other, and that's what Thomas was saying in his video, that that the Sibelius didn't sound like usual or the most single driver speakers that he heard, because it sounded like really, really like a darker, I would say. I haven't seen his Sibelius video a long while ago. I'm not sure exactly what words he used, but what I would have used, what words, is that it has like a darker tone, and it doesn't have that upper mid-range tilt. And this is true for this Daton driver as well. So just because a driver is a single driver, or a speaker is a single driver speaker, it doesn't mean that it has to have that mid-range forwardness, that mid-range boost. Because as you've seen in the case of the Fostex FE204, let's get back here. Yeah, we are going back here. You have like a straight tilt for the high frequencies. And what I have noticed, how it interacted with my rooms, that when I put them in a very small room and low-level amplification, then they were definitively mid-range forward much more than this figure. I would say then they definitively had a hump here that is not shown in this graph. But when I place them in a big room and with high-level amplification, then there was absolutely zero mid-range forwardness to them. They sounded like a balanced full-range speaker would sound, except that they don't sound like a multi-driver speaker, because single-driver speakers have a coherence that it's exiting. Okay, so they have a coherence that that is not there for the multi-driver speakers. And also what they have is that, well, it's 70 minutes already, so I'm not going to enter a new chapter here. So let's just finish with that, is that when talking about full range drivers, those without Wizzer Cone will sound very different from your typical single driver experience. And also single driver speakers with well integrated Wizzer Cones with high level application also will not have the typical mid-range forwardness that you expect in a in a not so sophisticated approach. So please like, subscribe, have an astonishingly good day. Bye bye.